Hi, and welcome to 1.2, the basics of functions and their graphs. The objectives for this section are to find the domain and range of a relation, determine whether a relation is a function, determine whether an equation represents a function, evaluate a function, graph functions by plotting points, use the vertical line test to identify functions, obtain information about a function from its graph, identify the domain and range of a function from its graph, and identify intercepts from a function's graph. This section has a lot of definitions, so they are already written in your notes for you, but I will review them. So a definition of a relation. A relation is any set of ordered pairs. The set of all first components of the ordered pair is called the domain of the relation, and the set of all second components is called the range of the relation. So domain is X, remember. And the range is Y. So for the first example, find the domain and range of this relation. So the domain is all the X values, so it's 0, 1, 2, and 3. The range are all the Y values. So 187, 212, 225, and 238. Simple as that. Nothing tricky when it's ordered pairs. That's the easy ones. You just list what you see. So the definition of a function is a correspondence from a first set called the domain to a second set called the range, such that each element in the domain corresponds to exactly one element in the range. In other words, X values do not repeat. Y values can. That is extremely important. So for example 2b, determining whether a relation is a function. Determine whether the relation is a function. My X values are 1, 3, 6, and 8. Do they repeat? Nope. Therefore, this is a function. So you don't have to write all that out, but this is really what we're looking for. The relation is a function. If the X values repeat, then it's not a function. Functions as equation. If an equation is solved for y and more than one value of y can be obtained for the given x, then the equation does not define y as a function of x. So for example, 3b, determining whether an equation represents a function. So if I have x squared plus y squared equals 1, solve for y. You want to get y alone. So I'm going to subtract x squared from both sides. Then I have to use my square root property because it's y squared, so take the square root of both sides. And we have to remember when we take the square root of both sides that we have to use our plus and minus out in front. So is this a function or not? Well, this is not, because when we have plus or minus, that means I have two separate values, the positive of the square root of 1 minus x squared and the negative of the square root of 1 minus x squared. So I have two answers. So if I have two answers, it cannot be a function. And if you remember from geometry, x squared plus y squared equals 1 is the equation of a circle with a radius of 1 and a center at the origin. Function notation. This special notation, f of x, reads f of x or f at x, represents the value of the function at the number x. So we're going to evaluate. If f of x equals x squared minus 2x plus 7, evaluate f of negative 5. F of negative 5, just substitute negative 5 in everywhere you see x. But when you're substituting in, make sure you use parentheses when you substitute a negative value in. Otherwise, it will evaluate it incorrectly if you don't use that. So when I evaluate this, I will have 25 plus 10 plus 7, which is 42. Therefore, f of negative 5 equals 42. It's kind of like an ordered pair. X is negative 5, y is 42. Your answer is always the y value of the ordered pair. So we have graphs of functions. The graph of a function is the graph of its ordered pairs. So we have the functions f of x equals 2x and g of x equals 2x minus 3 in the same rectangular coordinate system. Select integers for x starting with negative 2 and ending in 2. How is the graph of g related to the graph of x? So for the solution, we are going to set up a partial table of coordinates for each function. Then we will plot the points and connect them. So on your paper, on the left side, you can do your table for f of x equaling 2x. If I substitute negative 1, negative 2, 0, 1, and 2 in, my answers will be negative 4, negative 2, 0, 2, and 4. Plot those points on your graph. Then, on the right-hand side, I'm going to do g of x equals 2x minus 3. And when I put negative 2, negative 1, 0, 1, and 2 in, for that, I'll get negative 7, negative 5, negative 3, negative 1, and 1. Then I plot those points. So how is the graph related? Well, the graph of G is the graph of F shifted down 3 units. Notice the graph itself, it doesn't look like it's 3 units, but each line is 2 units instead of 1 unit. So just be careful when you're reading graphs because sometimes they won't do each line as 1. Next, we have the vertical line test for functions. If any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. So we have 2 examples there. For the first one, A, if I draw a vertical line, I can't draw a vertical line where it could cross more than once, therefore it is a function. For B, or D, excuse me, on your paper it's D, if I draw a vertical line, I can cross in 2 places, therefore it's not a function. Circles are not functions. Example 7. We're going to analyze the graph of a function. Use the graph to find f of 5. So, what are we looking for? Well, when x is 5, looking at the graph, it is about 400. The next question is, for what value of x is f of x equal to 100? So this time we're going to go to the y-axis where 100 is and see where it crosses the graph and get an approximation. And when I do that, it looks like it's right around 9 if you were to draw a horizontal line from 100. This will help. So if I kind of draw the line, that's 100. Oops. Right there. Around there. Okay, so I'm looking for that point there when x is 9. And with the first one, 5, I'm looking right here where it crosses. So, this is your favorite part, identifying the domain and range from a function's graph. To find the domain of a function from its graph, look at all the inputs on the x-axis that correspond to points on the graph. So, for the domain, we read left to right, left to right. For the range, we look for all the outputs on the y-axis that correspond to the graph. So when we're reading the range, we are going from the bottom to the top. So for 8a, identify the domain and range of this function of this graph. Use the graph of the function to identify its domain and its range. So first we're going to find the domain. The domain, I'm looking at the x values. So I'm going to look from here to here, and I'm going from left to right. My first x value is -2. My last value is 1. So I have all the x values between -2 and 1, and this is set builder notation. I'm starting at -2, less than or equal to x, less than or equal to 1. When you have the x in the middle, that means x is in between -2 and 1. It can be equal to -2, it can be equal to 1 because I have closed circles on the ends. For the range, oh, sorry, it's interval notation is just -2, 1 with the hard brackets. Hard brackets mean it's equal to. Okay, that box is what I was showing you with my lines. For the range, this time we're going to read the graph from the bottom here. Looks like we start on the x-axis and we stop up here. So we're going to go bottom to top. So my smallest y value is 0 and my largest y value is 3. So in set builder notation, it's 0 less than or equal to y, less than or equal to 3. And there should be a bracket at the end of that. And then interval notation is 0 to 3. Again, brackets because the points, endpoints are included. Okay, again, that's the rectangle there, looking at those y values on the axis. Let's try 8b. Same question, different graph. Find the domain, find the range. My domain goes left to right. So I'm starting at -2 and I'm ending at 1, but -2 has an open circle, so it's not included. So I'm just going to have a less than symbol there. So -2, less than x, less than or equal to 1. How that looks with interval notation is a parentheses versus a hard bracket. So it's parentheses -2, 1 with the bracket. The range is going to be bottom to top. So bottom, my smallest y value looks like -1. My largest y value looks like 2. So it's -1. It's equal to, because it's a closed circle, less than or equal to y, less than 2, because it's an open circle, so it can't be equal to. And that's a mistake. We have an open circle at 2, so this should actually be a parenthesis. So it's a bracket, -1, 2, parenthesis. All right. Identifying intercepts from a function's graph. So to find the x-intercepts, look for the points at which the graph crosses the x-axis. To find the y-intercepts, look at the point at which the graph crosses the y-axis. A function can have more than one x-intercept, but at most one y-intercept. If it has multiple y-intercepts, it's not a function. So let's look at this last example. Find the x and y intercepts. So the x-intercepts are crosses here, here, and here. So our x-intercepts are -3, -1, and 2. The y-intercepts, I have just one, and it's at -6. All right, that is it for today. There are no U-tries. I hope you were okay with most of that. It should have been a lot of review information.